Hello guys and welcome to another episode of the Power Logic. So it has been a while since my last video and today I'm gonna shift my gear a little bit. So instead of actually presenting the problems from the AMCs, I'm gonna actually start a new project which I'll name it as Structure Behind the Magics. And today I'm gonna start with the episode 0, which is an introduction. So basically what I will do in the future is so as I progress through the episodes, then there'll be so I'm gonna draw more connections with the more structural math, right? The algebraic structures like group theory and more rigorous and abstract math with the tricks in competition math problems. So that those tricks wouldn't seem anymore as some with as some very magical and sudden problem crackers, but actually something that um was structurally proved or derived from some algebraic structures. So a more rigorous way of viewing um these terminologies. Okay, so let's start with an example. So maybe you have seen examples like this, which is, for example, um the factorization like this. So a to the n minus b to the n is always divisible by a minus b, and also a n plus bn is divisible by a plus b when b is odd. So the second case is when n is odd. And also we have something like the parity arguments, right? Which is like mod n. So for example, you know this freshman dream, which is a to the p plus b to the p is equal to a plus b to the p. So this is some dream that we've always had during the high school because this is actually much harder to compute if you know the binomial theorem. But this seems to be much more elegant and clean. Right? So this is definitely not true. Well, it might be true in some very, very rare or very, very rare like edge cases, but most of the time this is gonna differ by a lot. If I can just check some examples and um, but then there are actually specific scenarios where this is actually true and the freshman dream is actually accomplished, right? So when so this is actually equal to this modulo p when p is prime. Maybe I'll actually use some different notation when q is prime, or q is a power of p. So this is true mod. Let me just rewrite it here. So this is a to the q plus b to the q is equal to a plus b to the q. Mod q is true when q is a prime or q is a power of prime. So no numbers like 2, 4, 8, 16, and 3, 9, 27, all of these, then this is always true. Isn't this very magical? Right, there are also some parity arguments like for example, like when certain polynomials is always going to be divisible by 2 and stuff like this. Right, so over the next few episodes, I will just start with explaining what group theory this magical structure is, and how all of these are suddenly, or even more complicated examples are suddenly related to this vast overarching algebraic structure. And I will see you next time.